Okay, so question 5 deals with a probability density function for the continuous random variable x, and it's given by f of x is the modulus of 3 minus x if x is between 2 and 4 inclusive, and 0 everywhere else. So I'd always recommend starting with a bit of a graph. So 3 minus x modulus is going to have an intercept of sort of 3, then at this point 3 it's going to be 0, and then it's going to pop back up here. So I might even do that in a slightly separate colour, because these two lines we're going to need to separate into their equations. So this is 3 minus x, but this is minus 3 plus x. If we do the two individual functions that make up that modulus. Next we need to look at our domain. So it says we go from 2 to 4 inclusive. So we're looking at all this area in here. So if it's a probability density function, this area should equal 1 unit squared. That's our definition of a probability density function. And it's pretty easy if we calculate this point and this point, that they're just two triangles and their area will add up to 1. So if we sub 2 in here, we get 3 take 2 is 1, so we get, that's the point 2, 1, and this is the point 4, 1. So now we need to find the probability that x is less than 3.5. So on here, let's find out where 3.5 is. It's there, so we're looking at all the area in that first triangle and a bit of this second triangle. So there's two ways to tackle this problem. We could either do the integration method, or we could just identify them as two smaller, geometric shapes and can calculate their area. So I'll do the geometric interpretation first because it's probably easier. So we've got two triangles, and I'll draw them out again. So we've got this one here, and that goes from 2 to 3, and it goes from 0 in the y to 1 in the y. So it's got a height of 1 and a length of 1, and the area of that equals a half base times height. So that's equal to a half times 1 times 1 equals a half. Now our second triangle, this one on this side, is a little bit smaller. It's sort of like this, and we've still got 1 as the length, but the height this time is when we sub 3.5 into here. So 3 minus 3.5 is 0.5. So this height up here is 0.5. So our area is equal to a half base times height, which is equal to a half. Now the base is 1, but the height here is a half. And I have made a mistake there. That only goes from 3 to 3.5 across here, so that's 0.5 as well. So I'll just erase that to make it look all good. So it's a half times a half times a half. So that should come out to be 1 on 8. So therefore, our probability that, what do we want? X is less than 3.5 is given by a half plus an eighth equals 4 plus 1 on 8 equals 5/8. So that's the probability that we're looking for. Now another method we could have used is the integration method. So I'll have a look at that on a new slide. So I'll just quickly scribble back what we had up over here. So we had this, and then this. Oops, that's meant to be touching down there. And then we had between 2 and 4, extend this axis, and we were looking for all this stuff in here. We said that the red line was 3 minus x, and the green line over here was minus 3 plus x. So our probability that x is less than 3.5 is given by the integral of 3 minus x, the red parts, I might even put that in red, 3 minus x between, so that was 2, and that was 3, and that was 4, so that one was 3.5, that's what we're looking for. So the red bit goes from 2 to 3, so this bit of our domain here, dx, and we add on to that the integral of, we'll do it in green, of minus 3 plus x between 3 and 3.5, and again dx, we can't forget those. So this is going to be a lot less fun than our regular, simple geometric approach, but we can do it. So this is just going to be equal to, I'll do it in blue, the integral, so this guy becomes 3x minus x, add 1 to the power, divide by the new power, and evaluate that between 2 and 3. Then we're going to add on to that minus 3x plus x squared on 2. And we're going to evaluate that by 3 and 3.5, which is the same as 7 divided by 2. So we know from our fundamental theorem of line calculus that if we're integrating for the area, we just take this value, sub it in to here, and then we just subtract away this value when it's subbed into here. So the red part's going to give 3 by 3, subtract 3 squared on 2. Then we're going to subtract away from that the green, which is going to be 3 by 2, minus 2 squared on 2. And then we're going to add on to that. And again, we'll do this bit in the red. So that's subbed into there. Subtract away from that subbed into there. So we're going to have the red section is minus 3 by 7 on 2 plus 7 on 2 squared divided by 2. And we're going to subtract away from that minus 3 by 3 plus 3 squared on 2. Now it's just a matter of cleaning everything up from here on in. So still in blue, we're going to have 9 minus 9 on 2 minus 6 plus 4 on 2. And we're going to add on to that minus 21 on 2. Oops, that's a terrible 2. Minus 21 on 2 plus, what's that, 49 on 4 divided by 2 minus, so minus 9 is plus 9, and minus 3 squared is 9 on 2, minus 9 on 2. So this is just, if we turn these into some easy numbers, that's just a 2. So we're going to have 9 minus 6 is 3 plus 2 is 5. So we're just going to have 5 minus 9 on 2 for the first one, plus the square root of, well, that's minus 21 on 2 plus 49 on 8. Plus 9 minus 9 on 2. So that didn't clean it up a lot, so we're going to need to go another line. So this first half is just, well, that's essentially 10 on 2 minus 9 on 2, so that's just 1 on 2. Plus, so we can turn this into, what's it going to become? Minus 84 on 8. Hopefully, if we times everything by 4 on 4. So minus 84 on 8 plus 49. So 84 minus plus 49. So that's going to be 35. I hope. And again, this is plus 9 minus 9 on 2, so that's plus 9 on 2. Plus 9 minus 9 on 2 is going to be, yes, plus 9 on 2. So we're going to have, this is a half, plus 38 on 5, plus 9 on 2. I have a feeling I might have got that wrong at some point. Okay, so there's the issue. So this is actually minus 35 on 8 plus 9 on 2. Sorry about that. So all we need to do is get this as an on 8 fraction. So we're going to have minus 35 plus, well, 9 times 4. It's going to be 36 on 8, which should be equal to a half plus 1 on 8. And we can recognize that as being 5 on 8, which is the same answer we got through the easier geometric interpretation. So if you can, try and avoid doing all this calculus, because it's pretty easy to make a mistake when you can just use the areas of triangles and stuff like that. So the next bit of the question says the probability density function of the continuous random variable x is given by blah blah blah. So still the same thing, but now we're looking at part B. Find the probability that x is less than 2.5 given x is greater than 3.5. So again, let's just set up what we're actually looking at. So we've got this bit here, this bit here. We've got that's 2, that's 4, this middle bit was 3. And I should have mentioned on all the other previous ones that if we were asked to actually graph this, we'd have to show that it's 0 everywhere else. So that little orange line is y equals 0 everywhere where it's not within that specified domain. So luckily for us, VCAA already asked us to find the probability that x is less than 3.5, and we found that to be 5 on 8. Now it's just this first bit that we're going to have to deal with here. So x is less than 2.5. So 2.5 occurs about there. So we're looking for all this area here. Now I'm definitely going to take the geometric approach this time. Again, still a couple of ways you can do this. Unless I'm wrong, we can have A and B as the heights there. C down here, and we can just work out that the area is A plus B divided by 2 times C. So here we'd sub 2 into here and find that that's a height of 1, so we'd have 2 comma 1 as that point. Sub 2.5 in here, and we should get that's 2.5 comma 0.5. So we should be able to go and write our area out as 1.5 on 2 by our C value, which is 0.5, which is the same as a half. So we should have that this is equal to 1.5 over 4, which is 3 on 8. Now the other way you could have kind of tackled that is we already knew that this little triangle in here was the same as 1 on 8. We'd found that in a previous question. So the total area of this yellow bit was a half. So a half subtract 1/8 is 3 on 8. This guy again. So we've now got the area there, which is the probability of x is less than 2.5. So I'll write that in. That's equal to the probability that x is less than 2.5. So our conditional probability rule says if we want the PR of A given B, we want PR of A intersecting B divided by the probability of B. Now the probability of B we have, and we've now got the probability of x is less than 2.5, which is sort of the A value. And luckily, the probability x is less than 2.5, so this black bit I'm just scribbling in now, is already covered in the x is less than 3.5 that I'm putting in with the straight lines. So hopefully you can see that their intersection, this bit right here, is equal to the 3 on 8. That bit and that bit are the same, and we can just sub in PR of B is this 5 on 8 value. So pushing that through, we're just going to end up with 3 on 8 divided by 5 on 8 equals the same as 3 on 8 multiplied by 8 on 5. As you can see, this and this are going to cancel, meaning that our conditional probability is just given by 3 on 5. And that's the answer to this question.